Right, in this video I'd just like to show you the easiest and safest method of cutting threads on a lathe without any fear of crashing the tools. Plus I'd like to show some of the recent tools I've bought on eBay for cutting the threads and also measuring the work. Now, if you're new to machining and you're making one-off components like this airgun pellet box I've made here, there is no need to actually cut a standard size thread. You can actually make the box to whatever dimensions you like, or any other component. And like this one here, I machined the lower half and cut the thread to size. I didn't use any gauges or wires. I just cut it until there was a nice profile on the thread, and then I machined the top half, or the lid, and I carefully cut the thread, bringing it out to size until the lid just screwed on. And that's a really nice fit, no slop in that. And you can make all your components using that method without any gauges for actually checking the thread or any wires. And this is a brass test piece I made last night, and I did this one the opposite way around first. I machined the top half here until there was a nice profile on the thread there, and then I thread cut the inside until the top screwed into it nicely. And again, there's hardly any slop at all. It's a really good fit thread, nice and smooth. And again, I didn't use any gauges to actually check the thread. Also, if you're making components like this with non-standard thread, you can use whatever inserts you like. I used a metric insert, A60, and the lathe is actually set up for imperial threads, and that doesn't matter at all. So using this method, it's much quicker and easier to do, less to set up. You don't have to change the gears on the machine much, depending on the pitch of thread you want. I didn't even look at that. I just cut the thread on this one here last night. It was actually set up for BSP thread. I think it's 3/8 BSP, and like I say, I used a metric insert, and you can see that it's a really nice thread. So it makes it much quicker and easier to do. And like I said, it's great if you're making components like this to whatever size you want. And to make it even easier, I'm not actually using the lathe motor to cut these threads. I'm using my crank handles, spindle handles, which I made. This one here for the mini lathe, and this one here for the Myford ML7. And if you use this method with the handle on the spindle, like I say, it makes it so much easier. You won't crash the tool into the back of face of the component, and you can almost guarantee that the threads that you cut will be exactly right every time. So to make a quick component like this with the threads on, I chose a size of 24mm, and if you're new to engineering, you need one of these books here. Zeus Precision book gives you all the data charts for threads or whatever. Excellent information. So the diameter I chose was 24mm, so I turned that exactly to 24mm, and then for this thread, the other half you go along in the chart, and the tapping drill for 24mm is 21mm. So the half that this one will screw into, this bore here would be bored to exactly 21mm. And then I turned or bored the thread undercut, and I use this tool here. You can get these cheap on eBay, a very good tool. It's a S10K SD UCR 07 tool. Takes a DCMT 070204 tip or insert, and you can actually use that to touch on the back face of the bore, go out to the diameter and draw the tool back to make the width of the thread undercut whatever size you want. And it's a great tool, and on eBay they're only £4.20 post free from China. And then you use a tool like this, or this is what you call a caliper clock, to check the actual size of the undercut, that it will clear the actual thread when it screws down. And I bought all these on eBay second hand. That's a Mitutoyo one, and you can get them in all different sizes, some with a longer leg on there, that's for a larger bore, and sometimes you can get them like that where they've been modified and ground away, and that's for doing very tiny bores. Great little tools, and you use them with a micrometer and zero them to actually get your bore size, or the, like I say, the thread undercut size or groove size. Another great tool I got on eBay, or this gauge here, second hand again, very good condition, is a dial depth gauge, and you use this one with engineering slips to quickly check the depths of bores or drill holes, and you zero that one again with the engineering slips, like I say, to quickly check the depth. And you can get the different spindles. I just use a bit of silver steel, and you can actually modify one like I've done there, and you can silver solder a foot on the end there, as long as it's nice and square, and you can use that in the depth gauge with the engineering slips again, and you can set it and zero it so you can actually check the depths of circlet grooves, and you can also use the foot and calculate the width of a groove. So it's a great gauge to have. They're quite hard to come by, especially in this condition, and it's amazing what you can actually pick up on eBay. Also, this is a nice tool here that I bought a while back, and this is a bore mic, and it's in imperial. I see most of them now are in metric, and you just use that to check the diameter of a bore very accurately, and that's a great micrometer to get. And another really nice little micrometer I picked up at my local recycling centre. They've got a sales department, and I got this one for 50p, and it's a inside micrometer. You put it in the side of the bore, wind out the thimble there and get a very accurate reading across the two ends to get the exact size of the bore. And it comes with various different length spindles for doing larger diameter bores. It's made by Starrett in Great Britain and it's number 124. They do actually come up on eBay quite often. So now I come to the manual thread cutting on my Myford ML7, and I've turned up this example here. This diameter is 27mm, and I've put a nice undercut in the back there, and I'm going to be using this tool here. It's got a A60 metric insert in it. These tools you can get from China for about £6.80 post free. Great little threading tools, and you can get a pack of 10 inserts for about £10. Very cheap, and I'll put the details of these tools that I'm using underneath the video in the comment section. And like I said earlier, I think the lathe is actually set up for a 3/8 BSP thread, so it's a non-standard thread, and you can use this method on the mini lathe or any other lathe as well to easily cut threads to whatever size you want. So it's basically touch on the diameter and wind it back a bit and engage the half nut ready to cut the thread, and you must leave the half nut engaged the whole time. You mustn't disengage it. And then you can engage the lead screw gear, put the handle on the back of the ML7 spindle and wind the thread tool in, and that one will miss. I'm zeroing my dial and taking it in about 5 thou. And I'm only taking it in 5 thou at a time. Take the tool just to clear the thread into the undercut. Another 5 thou. And it's best to wind it out. Remember where you were and take it back, as there's a danger of it unscrewing the chuck. Just remember where I was. Reverse the tool, wind it back, take it into same position and 5 thou again. So I just continue cutting it like that until the profile of the thread looks good under a magnifying glass. And then I remove that component. And then I put in the other half, which is already bored to the correct size. Looks like it's running fairly true. And then I use the internal threading tool with a metric insert. And like I say, I'll put the details of these tools under the video. This one's only about £6 as well, from China. And then take this tool in and touch on the bore. Engage the half nut and leave that engaged the whole time until the thread is finished. And you can wind it in until you hear it clear and you know that it's in the undercut. And then take the tool back, reverse, and take it in another 5 thou. So as soon as it goes into the undercut, you hear it clear, and then I back the tool off. Just remember where I was. And then bring it in another 5 thou. Just zero my dial. And then wind it out enough so that you can check the other component whether it's going to fit. So the most important thing to remember is to leave that half nut engaged and wind the spindle to get the tool back far enough. If you disengage the half nut, then you'll ruin the thread. So now just check whether that one screws in. There's still some way to go yet. Just a little bit tight. It's nearly going. And you just keep cutting the thread like that in 5 thou cuts until the component screws in, and you can actually hear that's a really nice fit. There's hardly any movement in that at all. It's a really accurate thread, screws all the way down, and I'm very pleased with that. And like I said earlier, it's a lovely safe method to do thread cutting on the lathe. There's no fear of crashing this tool into the back face of the bore. You can get a dead accurate thread every time. In fact, I've never had a failure when using this method. I've had a perfect thread every time I've done it. It makes thread cutting dead easy, and it takes away all the stress of having to have quick reactions when using the motor. So I hope you enjoyed the video and have seen how uncomplicated it is to actually cut non-standard threads, that you don't actually need thread gauges or wires to do so. You can actually use the components themselves. When they screw together like that, they're perfect. And you can quickly and easily set the lathe to whatever thread pitch you like. And like I said earlier, I'll put a list of these tools below that I've used. I'll put the tool number and the inserts that are actually used in the tool, and where I got them from and the approximate price.